of doing the test this time different. It's not a calculator and a non-calculator day, as I've been telling you. You'll have one answer sheet tomorrow, and that you will put all of your answers on there. And there's the calculator portion, which is where we're starting today, starts at number 7. That's also where we're starting on the test day. I know it's a little weird. Why didn't I change it around? It's just too much work. We're just going to start on number 7. So you'll get this answer sheet, your test, you'll have your calculator on your desk, and you'll do those 6 problems. Then you'll come up and give me the test and the calculator, and I'll give you the non-calculator portion, and then you'll finish that. So this is what you're doing tomorrow, these 12 problems. Then on Monday, same deal. We'll do the calculator portion of the FRQ first. Turn it in with the calculator. I'm going to be doing a lot of moving around these next 2 days, but that was just the easiest way for me to kind of do it. And you can write here, you can write on the back, okay? All right, so calculator portion. Let's talk about number 7. We are given an equation that represents an investment, so it's certain compounded blah, 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 and we're saying, how long will it take for our investment to double? And it even says our investment is $3,000. So the A of T is the total in your account after everything's been accumulated. So doubling 3,000, of course, is 6,000. So I'm going to start just by plugging 6,000 in. And I had some chats with several people in different classes about this problem in particular. Guys, you shouldn't be talking. And why do I have to show work on this problem? I can plug and chug. I can plug these different numbers in until I get the answer using other ways of doing it. And when you take the AP exam, of course, they don't care about your work except for the FRQ. Your multiple choice is multiple choice. You can guess, you can be smart, educated guessing, eliminating, and you give it 50-50, things like that. But for this part of the school year, I need to know that you know how to do the processes, okay? So plugging that in and solving for T, okay? So one thing that we've talked about is, well, this is an exponential function. It has a base with a power. Is to solve exponential functions, we rewrite them in their log form, and that's what I'm going to do. But before I do that, I have to get the base by itself. So I would divide both sides by 3,000. You certainly don't have to show this step. You could have just jumped to 2 equals this. Okay, and then I'm going to rewrite this in log form, okay? You don't need to write this. Let me just show you off to the side here. If this problem had a different base, let's make it a base 5, for example. To rewrite this in log form, I would start by writing the word log. The base of the exponential is the base of my log. Leave a space. That decimal goes over here. I'm just writing decimal, being lazy. And then 2 goes here. So that's how you would rewrite that one. Why is this one different? It's not really. E is a number. It's just an irrational number, 2 point blah, 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 blah. So they use E in place of that. And since it's a little different, it gets its own special log name called a natural log. So when your base is E, instead of using log, base 5, it's natural log base E. Now, I don't write the base E, because no base needs to be written on a natural log. It's only E. You'll never have anything but an E. Okay? If you wrote it in your work, I would not mark it wrong. Okay? It's not wrong to put a base E. It just makes me a little uncomfortable to write it myself, so I can't. Okay? So leave a space. The power, that decimal goes up in the variable, goes here. And then, remember, loner up in the sky gets his own way up side of the equation. And then the 2 will drop it right in there. It's a really great way of getting an exponent down on the ground so we can solve for it. And then the rest of this is just going to be calculator work. I'm going to pick up my calculator and divide natural log 2 by 0.0525. So natural log 2, be careful, mistake I keep seeing people make because they're getting different answers, is not remembering to put parentheses after it. Okay? You have to put parentheses there, or your answer will be off. And you get 13.203. So how to answer it? Let's be smart about our decimals. Not every decimal follows decimal rounding rules, okay? This is a real life problem, and I want to know how many years it's going to take. You can't say 13 years because it's more than 13 years. 13 point anything, even a teeny tiny decimal, is more than 13 years. So in this case, you would round up to 14, okay? Good? Number 8, we're given a log. Find its inverse, and then use limit notation to describe the end behavior. So inverse, switch the x and y, solve for y. How many times have we done this? So I'm going to go ahead and do that. Okay, oops, that's a y. Switch x and y, and I'm going to solve for y. Just like in the last problem, we had to get the base by itself. We had to get to this step before we rewrote it in its other form, log form. We're going to be rewriting log in exponential form. They are inverses of each other. And there is some cleanup to do here. How do I know that? Well, in a second, it's going to be 2 to the x equals this. And that skips right over the 2. Like, think about your normal process. Base 2 to the power of x, the arrows, which I'll write in the next step. That 2 gets left out. So that tells you you have to clean up the problem. Basically, you want to always have the log by itself. Log, and by itself, they're all part of the log, right? Log base 2 of this. So this has to be alone before you rewrite it, just like in an exponential, the base and the exponent have to be by themselves before you write it. Okay? Now we can go 2 to the power of x over 2 equals that. So that's 2 to the x over 2 equals y minus 3. Yep. That 2 right there. And then add 3. So my answer would be 2 to the power of x divided by 2 plus 3. Okay, that's not the answer. That's the function. So couple of different things you could do here. You could just reach into your brain and find the end behavior, what you know about exponential functions maybe. But anytime I am able to look at a picture to do domain, range, or end behavior, that's my choice. I just think it's easier. So that's why I said if you want to, optional, you can put that in the graphing calculator and look at the picture. So I put that in my graphing calculator, graphed it, and it looked, you don't have to graph it, but I'm just showing you. It looked like that. And then end behavior is so easy to pull off of there when I have that picture. So you know that, well, let's just say limit as we go. Let's just talk about the x's. The x's to the left and the x's to the right are going in those directions without bound, meaning nothing is cutting them off. There's no vertical asymptotes that are saying you can't go to negative infinity and you can't go to infinity. So our x's are going to approach infinity and negative infinity. But our y's have a problem because there's an asymptote. To the right, we're going up, right? To the left, we're approaching our asymptote, which is 3. You can see it on the graphing calculator. So just be careful picking the right one because they start to run together. I mean, just at first glance, they kind of look all the same, right? So just be really, really, really careful that you make the right choice there. Okay. Number 9, relationship between the level of sound, whatever that is, beta, in decibels, and the intensity of sound, I, in watts, percent, blah, blah, blah. Okay? Algebra. Here's an equation that has 2 variables. I know I'm going to have to solve for one of them, determine the level of sound. So I'm solving for beta. That's just a Greek beat. Beta. And they gave me this one. I mean, all that talking, you algebra people at this level, you probably could just look at this and say, oh, I'm going to plug that in there and solve, okay? Which is what I did. So let me go over that part of it. So 10 log, and I'm going to plug in what they gave me for I, and I'm going to solve. If this is just same bases with powers, you keep your base, subtract your powers. It's the same thing as if I said, you know, what is this? You would subtract them and get x squared. Just a 10 with the same base. So I would have 10 times log times, this would be negative 5 minus 16. So times 10 to the 11th power. Just negative 5 minus negative 16 in your calculator. Keep your base, subtracted those. Now, there's a couple different orders of you could do this in, but what I do want you to see is there's 10 log in the middle. What is log 10 equal? What does log 10 equal? 1. Don't forget the easy stuff. Remember, if you have the same base and the same number, it equals 1. And log 10 is a base 10, right, when you don't see a power there. So this right here, this equals 1. And the 11 is a power. You can bring it down to the front. So if you are a log, and this guy is a log, you're allowed to apply any of your properties. So that's how we get the 11 down. This becomes 1, and we do 11 times 10, or 10 times 11, and get 110. Okay? And you guys should be able to trust me this far into our relationship, right? If I tell you the test is like the review, I haven't broken my promise to you yet, you know exactly what to expect. I don't try to trick you. Haha, I changed them. I would never do that, okay? All right. Number 10 gives us a graph of a log, and we want to find the inverse function of that. So I looked at this graph, and I said, okay, they gave me 2 points. I don't like that one. That's a decimal, natural log 3 plus 2. That's why it's written like that. But 4,2 is a very friendly point. And if 4,2 is a point on this graph, then 2,4 is on the inverse, right? Flip the x and y, flip the x and y, flip the x and y, and all the different things. Table values, graphs, equations. So I switched the x and y. Then I just used my calculator and plugged in chug. I tried to plug 2 as x into all of them to find y. I don't really feel like we need to show work on number 10. I might not make you do that, because I'm telling you to do it in your calculator. So what I did, though, is when I got to choice C, when you put a 2 in for x, 2 minus 2 is 0. Anything to the 0 power is 1. Don't forget that. E to the 0 power is 1. X to the 0 power is 1. 5 to the 0 power is 1. Pi to the 0 power is 1. So e to the 0 power is 1, and then 1 plus 3 is 4. So when I plugged in 2, I got 4. That means that point is on that graph, so it's the inverse. Because it's the inverse. So this graph has a point they gave us is 4,2, so the inverse graph would have a point that is 2,4. You switch it. So that's why I used that point. So I just plugged in 2 here, I plugged in 2 here. Using my calculator, 2 here, until I got. It's kind of obvious. E to any power is a weird decimal. The reason we use E instead of whatever the number is because it's a crazy decimal. So really, E to the second power, we're not going to be able to get a 4 out of that. Just kind of looking at these, this is kind of an obvious choice. So I'll probably not make you show work on number 10. It's just calculator work. It's going to be just like that. Okay. Number 11, I don't know what a demand equation is. And I'm recording, so I shouldn't say it, but I don't really care what a demand equation is. I've got an equation. I can handle that. That's algebraic. I know how to handle equations. And they give me this that represents the new stand-up desk. The price is key, and the demand is X, whatever. So we're trying to find X, whatever that is. And I'll be honest with you, I didn't even try plugging P in for 300 and solving it algebraically. I just went right to this. So you might be able to, and I've not had time to try it. You might be able to, and this is not a show the work problem, so I don't care which way you do it. But if you wanted to on your own time, I'm going to when I have time, plug a 300 in here and try to solve for this X, similar to the one we did before. But let's do it this way too, so we can practice that. So what I'm going to do is always clear my RAM. Don't trust the person that had the calculator before you on a test day. Sorry, 300. It's 300. Okay, so what they're saying is this. So I think of Sadie. I think of you, Sadie, every time I do these type of problems, the intersection, because when I first taught you guys intersection problems, she proved me wrong about something. So I'm going to explain what I'm talking about here. I can't do two things at once. Okay, so what they're doing is, what is x when y is 300 using this? And so I could graph this, then I could look at the table, and I would go through my y values to find 300, and then my answer would be x. And when I first taught this, I said, you can't use your table to find the answer. It's hard to do that, or I think I said you can't do it. And there was a problem that Sadie said, oh, I did, and it worked. It doesn't always work, especially if there's decimals, and this one is like rounded. You'll see when you do it. So a really nice way to find an x given a y is intersection. We've done it, I think, on every test for like the last 3 tests. So we would go to our y sub 2 and put the 300 in. So the graphing calculator will graph both of those, and where y is 300, x will be whatever we want to find. So we'll see this here in a second. Now, if I try to graph it right now, I'm not going to see anything on my screen. And think about the y of that. The y of that is that our default window is just going out to 10 units in every direction. If you look at your answers, our possible x values range anywhere from the 400s to almost the 900s. So we're only going out to the right 10 right now. That's why we don't see it. Also, we want to be as high as at least 300, right? And we're only at 10. So we know at this step we have to go to our window. Now, I don't care about to the left, and I don't care about down. I don't care about anything negative. You could change those 0 to 0 if you wanted to. It's not necessary. But using my multiple choices, I'm going to go maybe out to the biggest number and a little further, like 900. Did you do 899? Yeah. Did you do 1,000? Yeah. Try. Nope. What did I do wrong? Nothing. I'm at snack. Sorry. I thought I had a line. So that's going to the right 900. So that will cover any of those possible choices. And then I'm going to go up y max to at least 300. Not just 300, because then my line will be right at the top of the screen. I might make it like 400, but those numbers are negotiable. Remember, when you graph this, if you don't see the intersection, go back to your window and change it, okay? But I made some good choices there. As long as I can see the intersection, that's what matters. So I'm going to hit second, calculate, and I'm going to go to intersection. So this is where 0, min, max, intersection. And so I'm going to hit number 5. And I need to find my cursor. And sometimes it's missing. It's not really missing, but I almost get a little piece of panic. Like, where is it? How do I get my cursor on both sides of it if I don't even know where it is? Now, and then I calm myself down and look at the bottom of the screen. It's telling us where our cursor is right now. I don't know why it's at 450, 435, but it is, okay? So I need to bring it down. So I'm going to use my right arrow button until it jumps in my screen. And you can see the progress, what's happening, where it's going. And there it is. Now I have it. There she is. So I'm just going to hit enter. Could I be a little further up or down? Of course. We've talked about that a lot. So enter. And it puts me over here. It always jumps to the other part of the graph. I don't really understand the whys of it. I just know that it's pretty free. It's not super strict with us about where we put the cursor. But basically, now that spot looks good. I'm going to hit enter. What it's doing is saying it's pinpointed those two. Wherever there is an intersection between those 2 points, it's going to tell me what that point is. And so guess yes. And you know you did it right if your y value is 300, because that's what the y value should be, right? We want that y, where y is 300, what is x? And there it is right there, and it's 741. Okay. All right. And last one of these was on your quiz, question just like this. There's no work to show, so you don't have to write any of this if you don't want to. I'm just showing you. what I did, I identified all the points on here. And the question, let me read the question. Here is f of x, the inverse. What is the maximum value of the inverse? So I see points, I go, okay, I can flip all those points, right? So these are the points of the graph, and then I flip them, right? So 1, 2, 3, 5, 8, 7. Here's the part, we have to go way back to Algebra 1 and remember, but we've talked about it here. What is the maximum value of the inverse, okay? G upon inverse, I just did x. But anyway, remember, max and min is how high or low a graph goes. That is dictated by the y value. That's why the answer is 7, okay? And you can see a common mistake could be picking that 8. Because you might just think, oh, that's the biggest number anywhere, in this one or this one. And you might just think of that. But understand the question, okay? Okay? All right, now let's go over the FRQs. FRQs aren't till Monday, okay? There is something on the second FRQ that we really have to talk about, so please stay with me. And then there'll be time if anybody has questions on 1 through 6 or something else, okay? So I am going to be more strict on Monday with my grading of your FRQs. I've been telling you this. I've been telling you this. I've been a little lenient about how you do your limit notation, and if you're not explaining it super well. Some of you write beautiful explanations, but for this test, I'm going to start being a little bit more strict. So what we have here is, and you know your first FRQ is going to be just like this on Monday. It's just going to be a different XY chart. So maybe it behooves you to watch this Sunday night again, or whatever. Okay, so we are given a function in this form. It has a base, x to the minus h plus k. So there's some left and right, up and down happening to our parent function. That's what that means, okay? They give us a table of values. We have to answer some questions. So the first question is to describe the end behavior of the function. So when I look at this, let's talk about the x's first. Going to the right, 4, 5, 6, 7, 8, they're getting bigger. Going to the left, 3, 2, 0, negative 4, they're getting smaller without bound, meaning nothing's stopping them. There's nothing standing out to me with the x's. So when I write my limit behavior and talk about the x's, I'm going left and right. And it doesn't matter the order that you do these in, okay? So one's going to be negative infinity, one's going to be positive infinity. But our y values, I see something happening here. But let's look to the right. As x gets bigger, y gets bigger without bound. Is another way of saying it, right? It just keeps going. There's nothing weird happening here, okay? So that's why going to the right, we're going up. 5, 7, 11, 19. That's positive infinity, okay? Here, where these decimals are occurring, that's where you zoom into. You go, oh, there's something happening there. And that something is an asymptote. There's going to be an asymptote at 3 because my graph, my asymptote is not letting my y values go down towards negative infinity, right? There's something blocking it. And that's that horizontal asymptote of y equals 3. Okay? And you can see that there. So there's my limit notation. What is the value of k? Well, k is 3. Now don't just say k is 3. I need an explanation. The reason is basically what I just said. Because as x goes to the left, y can only get to 3. That means there's an HA at that number. Okay? So explain it somehow like that. This part is sometimes confusing for us. Explain how you know the base of the function f is 2. How do we know the base is 2? Well, you may not have known it, but it's telling you it's 2. Why is it 2? Okay? So this is important. Understand this. When there is no h or k, if it's just b to the x or even a times b to the x, these numbers are super clear to read. It's going to be multiplying by a factor of 2, of 3, of 4. It would be like 2, 4, 8, 16, 32, 64. Multiply by 2, multiply by 2. But the minute we put an h and a k in, that goes out the window. There is a pattern. We just have to do 2 steps to find it. So I ignored the decimals because I have enough information over here to find it. So I just looked at what the pattern was over here. Add 1, add 2, add 4, add 8. Okay? And those are 2 to the 0, 2 to the first, 2 to the second, 2 to the third. So this is what's happening in the chart, but our b is still 2. Okay? So whether it's multiplying 4, 8, 16, 32, 64, b would be 2. Or if it looks like this, b would be 2. Hold that thought. I'm going to explain it one other way in a second. And then explain why. So as the x values increase by 1, y values increase by powers of 2 to the n. That 2 to the n has to be there. Real quick, look at number, you don't have to flip your paper. Just stay right there. In number 6, guys, look. Same idea. Here's a chart. Is this exponential or log and y? So the y values are increasing by 1, and the x values are doing exactly the same thing that was happening on that FRQ. Well, since it's happening to the x's instead of the y's, we know it's logarithmic, okay, instead of exponential. And look at the difference here. The input values, inputs are your x values, are increasing by 2 to the n versus a factor of 2. Notice the difference in the wording here. Same difference in the wording on your FRQ. Okay? Find the value of h, then write the equation. So I chose any point. I used 4, but you can use any point in the chart except the decimal ones because those are rounded. The k that we found in part B, the b that we found in part C. I have 4 variables that I can plug in to this function to find the fifth, which is h. So I plugged in these variables and solve. So subtract 3, get 1. So I'm going to write this step that's in red and show you something here. So we get to this part, and I have to solve it. And believe it or not, you do believe it, we can make these have a same base. So we could rewrite this in log form like we did on another page, and that's a lot of work. 1 can be rewritten as a base 2. Don't write this because I'm changing the problem. We've seen where that's a base 4, and you could do 2 squared equals 2 to the 4 minus h, and then once the bases are the same, the exponents are the same. So we can do that same exact process with a 1, because using algebra, we can substitute 1 for anything that equals 1, right? I could put 2 over 2 there. I could put 5 over 5 there, but that's not going to do anything for me. But they equal 1. But we learned that any base to the power of 0 is 1. So you can replace 1 with the base that we want to the power of 0. When the bases are equal each other, the exponents equal each other. And then you'll solve that and get h's. 4. So that's the work I showed there. And then we write the function. So there's no explanation, you're just showing the work, writing the equation, plugging in h and k. Okay. Inverse, we did that before, I'm not going to go through that. And then graph both on the grid. So you have choices here, you want to watch the clock, you could put it in your calculator, get points, and graph them. Or, here's the easiest way, and it's what I did. I put the asymptotes in. I have an asymptote at x is 3 for this one. So I'm going to have, y is 3, and that means I'm going to have one at x is 3. So I put the asymptotes in for the graph and its inverse, and then I just used these friendly points and sketched the graph. So I graphed those points, made that, and then I flipped them for those. I flipped them. I graphed that, and then I flipped them and got that one. But whatever you want to do to graph them. Use your graphing calculator, use those points. But show your asymptote and the 2 graphs on the same graph. Okay? All right, one more FRQ. This one has given me problems. So I redid this problem, part B, 1 and 2. I've kind of revised it. I did scan it again, put it on Canvas, and I wrote on there, revised on 12.7, FRQ, calculator, no calculator FRQ. But I'm going to go over it with you right now, okay? So here we have another exponential function. This one has an A in it, doesn't have an H. They're calling KC. Who cares? You can call it. Have it on your paper. All right. So A in this one, they give us what this is. Okay. So that C instead of being K, doesn't matter. We can call it Hitler. It doesn't matter what you call that. If you know anything about exponential functions, which you do, C or that number right there is what takes your graph up and down, okay? So they give us the graph. There's some points on it. Let's see what the first thing is. What is the value of C? So C, when I look at that, that's just like K in the other problem. That is my asymptote. That is how high or low my graph is allowed to go. And in this case, it would be negative 1. Why, though? What is the reason? Because y equals negative 1 is the asymptote, the HA. The limit as we go to the right is negative 1. So anytime you don't get to travel without bounds, something stopping you, that is an asymptote. All right. Part 1 and 2 on this. So I took out give a graphical explanation. I just want you to explain. So I'm getting excited because I found a way to really explain this better today. So I was trying to help kids yesterday afternoon that were here after the testing, and we were getting deep discussions about it. So anyway, how do we know if A is greater than 0 or less than 0? That's what it's asking. So code for positive or negative. Is A positive or is A negative? Really easy to tell. And it is this explanation, but I'm going to explain why. A is greater than 0 whenever your graph is above your asymptote. A would be less than 0 if the graph was below. Let me explain, okay? So here is the graph that we're looking at right now. Totally not perfect. We just care about the shape, okay? And we have this asymptote. All our points are above it. Why? Here's why. If all my points were below it, it would look like this. If I flipped that over the asymptote, it would look like this. A is greater than 0 here. A is less than 0 here. And here's why. You already know why. When we have been working with exponential functions a lot at the beginning of this chapter, we didn't really do H's and K's. A was your your y-intercept, and if A was positive, we were above the y-axis, x-axis, and then remember what happens if there's a negative in front? It flips, right? That's a flip over the x-axis. Now we're flipping over the asymptote, okay? Because the parent function, before we had h and k, our asymptote was this line, y equals 0. We flip over it whenever a is negative. Well, we move that asymptote because now we have a C or a K, whatever you want to call it, either down or it could be up. It doesn't matter where it goes. What you do is you look at your points. If all of my graph is above it, that means I didn't flip over. That means A is positive. If all my points are below my asymptote, that means there was a flip in there, and that A would be negative. That's the easiest thing, really, if you understand the A value being positive or negative. Okay? So in this graph, A is greater than 0. Why? All my points, or the graph, is above the HA. Okay? The second one's harder to understand. Okay? B can't be positive or negative. It can be greater than 1 or between 1 and 0. Okay? Those are the choices. So B in this situation is like 1/2 or 2/3. It's not quite 1, but it's not less than 0, meaning negative. Okay? That's what that means. Right? So how do I know that? Well, in this graph, B is decreasing, which means decay, which means B is less than 1. So it's decreasing. But you also need to throw in that A is greater than 0. Why? Okay, here's why. A is less than 0 here, right? If there's a flip, A is less than 0. But, this is confusing, the B value is the same as before it flipped. So in this situation, this graph also is between 1 and 0, just like this one. So the reason why is because you judge a graph's increase or decrease before you flipped it. So before it was below the asymptote, it looked like this. That's when you make this judgment. Then it flips. So anytime you have a graph that has an A that's less than 0, you have to think, where was it before it was less than 0, before I flipped it? And wait, I didn't graph that right. Sorry. It didn't look like that. It looked like, let me do it red. It looked like this one. I went the wrong way. It was like that. And that is decreasing. Okay? That's confusing. If you want more examples of that when I'm done going over the rest of this, I can do that. Okay? So I'll come back to that. All right, so that's where I came in. So when you tell me about B, you're going to pick which one, and your explanation is because it's decreasing or increasing, and you're going to tell me what the A is, right? But bottom line is this. You're about to do your algebra, which I think you guys will be fine with. Do this algebra stuff to get your equation. Make sure it matches what you said, okay? A is greater than 0, and B is between 0 and 1. Because I'm going to give you partial credit, even if you don't explain it right. I mean, how many points could this really be, right? So I don't want you to stress too much about it because I feel like I'm really explaining it better today than I have in the past. I'll take that on. So do the best you can with this. I will be very fair with the points, though, right? All right, third part, use your points. What we're trying to do is use the points on the graph to find the values of A and B and write the equation. So I'm going to add that to that. Make sure you, and write the equation, okay? So use the one that's an intercept. That's a tip. That's an intercept first. I know, it's been happening all day. Sometimes you just do it over there. So 0, 1 is one of the points on there, and I'm just plugging into this right here, okay? So I have my C value, right? C was -1, and I plugged in X and Y. Beta 0 is 1, and I get A is 2. Then I use a different point. It doesn't matter what other point. I picked -1 and 3, and the A I just found, and the C that I already had, and I plugged all that in and solved. And then I wrote everything in the equation. Okay? So you can go back and do all that if you haven't done it, but you can use this key or whatever to do it. And then I did inverse. Got that equation. Switch X and Y, solve for Y. We've done it a few times. And last thing I want to say before you guys ask questions is the easiest thing to find domain and range is from a picture. That's how I started this whole lesson, is being able to look at the picture of a graph to do end behavior or domain and range. So the hint I'm giving you here is we already have a graph of the actual function right here. So I can identify the domain and range of this, and then to find the domain and range of the inverse, I just flipped it. So I could look at that picture, and then I just flipped it down here. Or however you want to do it. Let me just do it. I'm exhausted. Okay, questions? 1 through 5, anything I went over here? I know I went kind of fast through some of these. How is, wait, where, what? Oh, that would be +1. No. So, A times 0. So you understood the plug-in? Yeah. So, e to the 0 power is 1. That's times. These are multiplied together. So that's, like, I'm really showing you the steps here. 1a. Okay. In part 3 of that? Well, because it's asking for this function. It wants me, or sorry, g of x. It's asking for, write that. So I need this number, I need this number, and this number. I have this one. It's -1. We found that to begin with. And I need to find a and b. So that's what I was doing there. So I just found a, so now I know a is 2. What's b? So I had to do another equation to find b. So that's just the process. I just used the intercept to find a. Then I used everything I have now
Just, you ask me a question and you're looking at him. So, just use algebra and the points in the thing to find those. Actually, just A and B. I already had C. What else? Does anyone want me to do more examples of like 1 and 2, like to explain that better? Most of you are looking at your phones now, so I think you're done with me. Let me know. I'm going to stop the recording, but if anyone has a question, I'll come over to you.